Okay, good morning. So today's lesson is all about compression. So lossy and lossless compression. We want to make sure that you know why you'd want to compress files and what the advantages and what the disadvantages are of both lossy and lossless compression. So what does it mean? It means squeezing something. I have some stress balls that I'd like to give away as prizes. I was thinking that, like Bulford Computing stress balls. And as you squeeze them, they get smaller. And it's the same kind of thing with a file. You can squeeze a file to make it smaller. Why would you want to make it smaller? So that it takes up less space on disk and so that you can download it faster. If you do reduce the file size, well, obviously, then the file size is reduced. How ridiculous. Why do we compress stuff? We've talked about these two main reasons. If you've got limited capacity on your phone, then if you compress all of your data, then you'll be able to store more on your phone. And if you want to download lots of stuff, if you zip it up or compress it first, then it's going to take you less time to download it. Two approaches to compressing. Both are better than each other. Both are inferior to each other. It depends on the scenario. You've got lossy and lossless. What are you losing is the most important question. Yeah, good. So we're losing quality. So it's particularly helpful to talk about this in terms of images and sound. A bitmap image, you looked at this a couple of weeks ago, is where every single pixel is represented by an individual number, which represents the color. That is hugely wasteful in terms of disk space. So you will hopefully know that there's the difference between a bitmap image and a JPEG image, where a JPEG image takes up much less space on disk. And we'll explore that in Photoshop today and get some examples. But you can have lossy compression, which is going to be a dramatic reduction in file size, but it looks blotchy and nasty if you do it too much. And lossless, where you still manage to reduce the file size, but maybe not as much as you would if it was lossy, but it looks pretty good. It looks identical to the original. Lossless means it's possible to go back from the compressed version to the original one, because you haven't lost any fidelity, you haven't lost any quality. So here we go. Advantages of lossy. You get the biggest compression ratio, as in biggest reduction of file size. And usually it's not noticeable by human eyes or ears. Well, I think human eyes and ears can detect it, but it's still recognizable. So you can get a massive reduction in file size, but the reduced size version is still recognizable. Disadvantages, well, it does sound or look not as good, and you can't go back to the original from it. Something has been lost. By definition, it's lossy. Lossless is a form of encoding because you can reverse it. You can go back from it. You can get the original back from it. You don't lose anything because by definition it's lossy. But the compression ratio is going to be smaller. What do I mean by compression ratio? I mean the file size of the compressed file compared to the file size of the uncompressed file. Come on, here we go. And it depends what you're using them for. It's a trade-off, it's a balancing act. So sometimes, if you want to absolutely minimize the size of the file, then you can do that, but it's going to take you a long time to compress it. So you might want a faster algorithm that ends up with a larger file, but doesn't take you 3 years to be able to compress it all. Sometimes, if you are short on storage, then you want to go for size over speed. And sometimes it's a case of, well, you cannot afford to lose any data at all. If you're dealing with images and sound, it's usually fine to lose a bit of quality. But if you're dealing with an Excel spreadsheet or your Word document, you don't want to suddenly compress off a sentence or a file because you'll completely corrupt it. So that's all the theory really today. We'll start with the easy bits at the beginning of P17 in half term 9. Tell me those two reasons to reduce size and transmission time, and give me some real world examples. I'll give you a couple of minutes before we move on to activity 2 and watch the video together. So we just watched the video together. If you're at home, you can watch it yourself. We said that lossy is fine for audio, but not great for text files. You want lossless there. You need lossless for documents. You can have lossy for video and images. Executable files, you really do not want to lose a single bit. It must be lossless. So I'll let you work through this one whilst I open up Photoshop. We're going to do our own investigation. I think I've got Photoshop installed here. So when you get to the last activity, you need to find a nice high quality picture from Google Images. I'm going to go for a lobster. Plop it into Photoshop, Control N. There is a link to Pixlr, which you can use at home for free if you want. It's a similar kind of thing. And then hopefully we can paste that image in. So I've got an image. You need to make sure your original image isn't looking nasty. So if I zoom in to 300%, eventually it'll get pixelated if you're above 100%. So you can look at the view at the top here. And then it's File and Save for Web. This is where you can choose the file format and the amount of compression that you've got. So in the video, they said that low quality is the lowest that we could get, and that wasn't strictly true. All it did, it was just setting quality to 10. You can take quality all the way to 100, and then you can see the file size, the original file size with the quality set to 100. Let's see, it's 14 megabytes. So raw uncompressed is 14 megabytes. Why? Because remember, we calculated we did an expression for the file size. Width times height by color depth divided by 8 to get into bytes, divided by 1024 to get into kilobytes, kibibytes, divided by 1024 to get to mebibytes. So even on 100% quality, JPEG's managed to get this down to 4 megabytes. So that's a compression ratio of 4 to 14.5. Pretty impressive. But if we take the quality right down, the algorithm is more assertive, more data is lost. We've got down to 281 kilobytes, but it's actually relatively good. What do you see? Well, you don't actually see pixelization. The video was wrong there. You see compression artifacts. If you look closely and carefully, you will see some blotchiness. They're not pixels because they're not all the same color, but it's defined this image by squares. Can you see that if I zoom in enough? It's split the image up into squares, and it's kind of said, right, this is a gradient ramp from this color to this color, and that's how JPEG works. It kind of identifies patterns and gradients. What it also does is reduce the number of colors available. So a JPEG can only have, I can't remember how many colors. I think it's 16. I can't remember how many bits. Maybe research that. I think it's 16-bit color maximum. If you take it down to a GIF, that's only 8-bit color, so 256 colors. You can see there's some banding between colors now. It's actually a larger image. But you can see what happens if you reduce the color palette. The file size will go down, but you've lost that saturation. You've lost the range of colors here. I go down to 2-bit color. So we've got 4 colors to play with. Looks pretty nasty. So your job is to take screenshots of this file save for web so that I can see the file size. The only problem here is it doesn't have WebP, because WebP is a new file format which is better than JPEG, and it's not supported by the version of Photoshop that we've got. So feel free to change that in your Word document to maybe GIF, or to use an online one to see if you can convert the same picture to WebP and see what the file size is. So just open up Photop or Photopia, depending on how you want to pronounce it, and this shows a WebP. There's a lot of work behind the scenes in lots of websites to replace all JPEGs with WebPs, because WebPs allows lower file size for better quality videos. If you can make your images smaller on your web server, then people are going to spend less time waiting for your web page to load, so they'll be happier, and your web server will consume less network resources and less CPU resources, so it's going to be cheaper for you to run. There's a lot of search engine optimization and web server optimization that can be done by using image compression. So here you can see we can take an image down to 7.2 kilobytes that was a megabyte. That's a huge amount of compression. Let's have a look and see what you can do on JPEG and see how that compares. So if you go for full quality in a JPEG, what's it going to be? Just less than 1 megabyte. Lowest quality on the JPEG is still 7.1 kilobytes, but look how terrible that quality is, the visual quality. File size is the same for WebP, but the visual quality is terrible. So when you've filled in all the sections of P17, please make sure you save it and then upload it to half term 9 data 3. And I'm recommending to people who are in the lesson that they spend the rest of the time going back to CT17, which is what we did yesterday, because that was quite a challenging one. We'll need a lot more time and practice on CT17.